So guys, we are about to take what is basically the most important step in this class. Okay, so this is very exciting for me. Obviously it's F-Talk 2. I already said that F-Talk 2 is used more often. So it's kind of like more importance, but it wouldn't exist without F-Talk 1. So let me recapture a few things that we know now. So if I have this function, we know that g prime is f of x. Now, let me write this. I'm going to do something really silly, just because. That means that we know this. Ooh, that's ground shaking. Okay. What if I took this side's antiderivative? I must also take this side's antiderivative. Of course, what you do to one side, you do to the other side. What is the antiderivative of this function?
Big F.
Good, big ass f. What's the antiderivative of this function?
G.
G. What else goes here? Plus c. Okay. Now listen, I could have said, if this guy's derivative is this, then g must be the antiderivative. That's basically what we just wrote. G is the antiderivative of this. So read with me. That by itself is huge. This is everything. So just to really take this all away, can somebody help me out? We have this definition up here. What in all of hell would g of a be? How do you figure out g of a? But what's the first level thing to do? How do I figure out g of a? What's the immediate thing you could do? Plug in a. That's insane. Can somebody tell me what this would mean? I didn't tell you what f is, did I? I didn't tell you what a was, did I? I didn't tell you shit, but you can tell me exactly the answer to this. What does that want me to get?
Area.
The area
Under the exact
under the function ft
of the same point.
from a all the way to a. So how wide is that?
Negative.
0. So I don't give a shit how tall it is. What's the area?
0.
0. Anytime you have a width of 0, your area is 0. Somebody with me? So g of a is 0. Because if I start at a and I don't go anywhere, how much area have I picked up? None. Let that make nothing but sense. So everybody cool with just that by itself? So I could give you like the ugliest whatever the shit, sine x, natural log of x, blah, 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 and I could say from 7 to 7, if I really wanted to, yes? This would be 0, yes? I don't care what I put in there. If I go from 7 to 7, the area is 0. You ain't got to pick up anything if you don't go somewhere. Okay. Sounds like a life lesson, kids. No. So, I'll want to investigate. So now we know this here, yes? Yes, and we know this here. So this is going to come into play here in a minute. Using this, can somebody help me out? What is f of b minus f of a? Just using this. And we know what big ass f is, don't we? It's this. So what is big ass f of b? Tell me, what's big ass f of b?
G of
G of b plus c. Minus, what's big ass f of a?
G of A
G of a
minus
plus c, yes?
plus-
Okay. You're all very excited. We're sitting there watching this guy play with letters all day. Okay. What happens over here? The c's cancel. Yes, c minus c. What would we say g of a was? 0. So what is f of b minus f of a? G of b. Now, what is g of b? Let me just stop. Everybody just stop for a second. Because it is so easy to get lost in the sauce here. G of x is defined.
Where did the zero come
Just a second. G of x is defined. F of x is defined. Not all the way, but enough to work with. What the what?
from? The zero, the G of A to the zero.
What's G of A?
0.
Why? Because what's the area of something from A to A? The width is 0, so the area is 0. Yeah. What is G of B? Go to the very top. What's G of B? What's G of B? What's G of B? Integral from A to B. F of t dt. And what we just say that G of B equals? F of B minus F of A. Do one more. If I do one more thing, we'll get F talk 2. Remind me, what is capital F compared to something about G? What is G built off of? The area under lowercase f, right? And what is capital F? That's this guy's antiderivative. Yeah, big ass F is an antiderivative. So if I do one more thing, do you guys remember way at the beginning, why did I have to call this f of t? Because I wanted my variable to control how far I went, correct? Is there still a variable in this integral?
B.
No. A to B, those are defined things, yes? So I no longer need to make that a t-axis. I could just make it an x-axis again. Jeff, x. All right, now, I know right now, you're going, oh, okay. Way to go, Jeff. Got a lot of letters down there. It's amazing. What we just did is, remind me, what does this symbol mean?
Area.
The area under F
of
from
A.
A to B. What is this? Antiderivative of the function, yes? You guys with me? And this is just saying, okay, to evaluate this, do I have to do the whole frickin' limit as n goes to infinity, sum I equals 1 to n, f of x, y, do I have to do all that? No, I just have to find the antiderivative of this and then shove those dumb things in. That's what we just proved. F talk 2 connects finding the area with finding the antiderivative.
So the fundamental theorem of calculus part 2 is antiderivative of the area is how you get your
Antiderivative is how I get the area.
Okay. So can you just
You ready? We're gonna do an example. In fact, we're gonna do this example. We're gonna do this whole problem again, just the shortcut way. Sort of like when we found the derivative of x squared using the limit definition of derivative. It took a while, and then we went 2x because that was a shortcut. All right, so we're going to do this whole problem again. Remember, I took the whole paper and I need more room. Yes? So here's, everybody got this? This is huge. This is F talk 2. This is it. This is F talk 2. This is everything. This is going to rule the rest of the semester. I don't know how I could put more exclamation marks on that. Except maybe literally. Little stars. Maybe like eyes looking over. Like, whoa. Okay. All right. I think we get it. Whatever, Jeff. That was funny. Shut up. So if I want, remember, I had you guys write, in fact, here. Sorry. Where? What? Who?
That's not
Get the face. No. All right. So here, you guys can do this on another sheet of paper. Yes? But you remember I had you guys all write this down?
Yeah.
You remember some of you guys are like, all right, I'll write it down. Well, here, we're going to do it now. What is my little f of x? Where's little f of x? You can do it. Where's, yeah, this thing. So what's the first step in doing this integral?
Find its antiderivative.
I want to find what big ass f of x is. Can you guys figure that out just by looking at this?
X to the fourth.
No. No. So, the number out here doesn't just go up there. What's the power currently?
X
What's the power currently?
1.
What's the power currently?
1.
1. What does the power always do when you take an integral of a
Goes
polynomial?
up, so it's gonna be
Goes
x
up 1. Yes?
2x squared.
Yeah, so this would become, so you could do this. 4, what's the integral of x? What's the antiderivative of x? X squared over 2. So this is how you could always do this. You could always just make the constant go for the ride, and then look at the x piece. How do I do x squared? It would become x to the 3rd over 3, yes? How do I take the antiderivative of something with a power? I make the power go up by 1 and a divide by it. And if you think about it, that's the exact opposite of a derivative. A derivative, I would multiply by the old power and make the power go down by 1. So here I make the power go up by 1 and then I divide by it. Everything is the opposite because it's the opposite operation. So I get
2x squared minus 1 over 3x to the 3rd.
So, how do I evaluate this then? By f top 2. It would be big SF of 3 minus big SF of
1.
1. Yes. So, what's the steps to evaluate what's called a definite integral? Because it's got definite endpoints. Find the antiderivative, shove the endpoints in, take the difference. Compare that to how long it took us to do this problem. Yes? So what is big ass f of 3?
You plug in the 3.
No way. So it'll be 2 times 9 minus 1/3 times 27. Yes? So it's 18 minus 9 is 9. Is that cool?
So,
Is that alright? You guys
Yeah.
with me? Plug a 3 in. 3 squared is 9 times 2 is 18. 3 cubed is 27 divided by 3 is 9. 18 minus 9 is 9. Yes?
Yeah.
Okay. And what's f of 1? 2 times 1 squared minus 1/3 times 1. 2 minus 1/3 is what? 5/3. So how do you figure out this? It would be f of 3 minus f of 1. And what is 9 minus 5/3? This is 27/3 minus 5/3 is?
22.
And if you guys remember, is that what we got before?
Yeah.
Yes. 22/3. There it is right there.
sorry. Would you be able to just write an example, please?
To do what?
One more example, please. Yep.
No, that's the only example I'll ever do. No. Obviously, I'm going to do several more examples. Yes?
Well, so you literally just take the derivative and then plug in the 2 points and subtract.
Yep.
Antiderivative.
So, real quick, just to remind you, here is the problem. Here is the work we did. Here is the same problem. Here is the work we did. Yes? This is the official technical idea behind this. We then took the idea and we built on it and we noticed a shortcut. We noticed the connection between this question and the antiderivative. And that's what makes a shortcut. Now, what's going to make an integral question harder is when I put funkier ass questions in here, funkier functions in here, yes? Okay. Let's try some more examples. I wish I could, well, let's see. Let's do, what about the integral from 1 to 5, what do you got, Jeff? Blah, 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 blah. Let's do, I like the look of concern. You can do it, oh, I know.
3x.
No, I'll just make it something like x minus 2x squared. There we go. I like it. I like it a lot. So let me show you some shorthand ways to write what we did. Can somebody help me with the antiderivative?
Yeah, it would be x second divided by 2.
Yeah.
Or
1
one
x
half,
squared.
one
Or
half.
either way's fine. Yeah.
Minus x to the third 2 over 3 times
Yeah.
x to the third
So it'll be 2
over 3
x to the third over 3. I like it. And then here's the shorthand way
plus c
to write all this shit. Oh, by the way,
plus c.
I love you guys. Oh, over here, do you notice what's always going to happen? If I would have put plus c here and plus c here, what's always going to happen? And this is where students forget you need a plus c, because when it's a definite integral, the c's always cancel. So you don't need plus c when it's definite, and so you suddenly forget that you do need plus c if there are no numbers here. And we'll do some examples like that in a minute. But here's a shorthand way to capture what I got to do. I draw a line, and I put a 1 and a 5. And what this symbol means is take this and evaluate it between 5 and 1. So that means plug a 5 in, minus plug a 1 in. So it's just a shorthand way to write what I need to do next. And then you get whatever the shit you get there. Let's see. Bless you. 70 something. You guys have calculators, you can help me. Yeah, that was 26 would be 42, 84. Minus 84 is negative 71.5, so that's plus 1/6. I would say it's roughly negative 71.3.
For 5.
What is it?
For 5 it is.
No, I mean for the whole thing.
Oh.
Holy shit, I was off.
Negative.
Oh no, I forgot a cube on my 5. That's funny, Jeff. I was really worried about
The
myself.
final answer is.
There we go. I'm not too far off. Negative 70.666. Now, the answer is negative. So that's a negative area. So if this was a flow of cash, that means the cash is flowing away from it. Which, happens. So again, negative area is fine. So what does that mean about my function? It dips below the x-axis for most of the time between 1 and 5. That's why it became this negative big number. Okay, maybe. Maybe?
So negative 212 over 3 is the final answer.
Yeah, something like that. What about this? Here, let's try this. You ready? All right, let's see. Integral from 0 to pi over 4. Sine of 2 theta d theta. Say again?
Does that say sine of 20?
2 theta.
Oh, 2 theta.
There.
And then d theta.
So when you see this problem, what's the first level you have to do?
Find big gap.
You need to
Find the antiderivative, find big S F. So that's section 4.9. And the second step is freaking algebra. You just plug shit in. Well, in this case, it'll be pre-calc because of the trig. So what is the antiderivative?
F of theta is equal to cosine.
Careful.
1/2 negative, or negative 1/2
1/2 cosine.
So let me do this one step at a time. You're exactly right. So it'll be sine comes from negative cosine, yes?
Yeah.
But the inside is 2 theta.
So negative 1/2.
This can't be right, so I gotta divide by 2, yes? And I have to evaluate between 0 and pi over 4. So you get negative cosine twice pi over 4 is pi over 2. Minus negative cosine twice 0 is 0. Jeff. Alright, let me stop for a second. All I did was get the antiderivative. Then I plug that in, and I plug that in. And I take the difference. So be really, really careful. I mean, negatives find a way to mess us up. That's negative, and I'm subtracting. So of course that's going to make plus. What is cosine of pi over 2? 0. Beautiful. Cosine likes x. Pi over 2 is on the y-axis, so of course it's 0. No part of the y-axis is x. So that's 0. Minus a negative is plus. Huh?
Wasn't it pi over 4?
It was, but what's the first thing I do to it when I plug it in?
Oh, yeah.
Okay. Plus, what's cosine of 0?
1.
So the area from 0 to pi over 4 under sine of 2 theta is 1/2, which is neat. I've declared it as neat, so it is so. How do you guys feel about this? This is section 4.9, which in the context of our class is old news. So the first step to an integral problem is to find the antiderivative. And then once you have it, you plug the limits in. Yes? Now the only difference between a definite integral and an indefinite integral, that's a definite integral because there's numbers here. So if I solve this question, that is an indefinite integral. Here's what's really silly about this question. If I see an integral with no numbers, there's nothing there, that is just saying what's the antiderivative. So what's the antiderivative of cosine x?
Sin x.
So close.
Negative.
Negative 9.
Further away.
Wait, sin x.
So close.
Plus.
Plus.
Yeah, okay. Sorry, you're good. Listen. No, you're fine. It's a focus thing, right? I do the same thing. I make stupid mistakes because I'm so focused on making one point, I forget to do something else. It's easy to make a mistake.
It's gonna say negative sign.
This is why I'm saying you might want to put a plus c. So why did I not have a plus c up here? Because what the plus c's do? Cancel, because I'm taking a difference between two outputs of the function where the plus c's in both. So of course they cancel. Here, why doesn't it go away? I'm not taking the difference of anything. So of course it's still there. Maybe. So, if you take that handout from earlier and you turn the page, do this. By the way, real quick, let's do this. All of these up here are just find the antiderivative. Let's do this first. Do these first, number 2. This is the real new stuff. This is section 4.9. This is the new stuff. Try the first few of these and then I'll catch up to you. Let me know if you need some help. Let me get a clean sheet up here. Let's see. Do I have a clean sheet? God damn.
Or antiderivative. What?
There it is.
No. So these two cancel out. So you're stuck with x cubed and then the
There.
1. Antiderivative of 1 is just x. So now c.
And we do this.
Oh,
You should still do a plus.
Well, you don't really need it. Yes,
Don't worry, we'll come back and do number 1, but let's look at number 2 first.
So 26. Is that what you think?
So 27, so it'd be 27 plus 3. Minus 2.
Oh wait, yeah, plus 6, plus 8. Yes. No.
30.
30 minus negative 2. is f of negative.
3 to the third plus 3, sorry. 3 to the third plus 3 is 27 plus 3 is 29, sorry. Minus 1 to the third, which would be
Yeah, 27 plus 3 is 30.
Yeah. Yeah. Okay, so it'd be 31. Because this was a negative sign.
Mhm.
This was a negative. So this becomes positive. So 1. And this one becomes. Negative.
Next one. Tangent. No, it's just tangent. That's tangent of zero.
No, it's not 0, it's theta. Be careful.
Yeah, but you gotta plug in the.
Yeah.
Well,
Wouldn't it be
just tangent divided by 2,
What's that?
right?
wouldn't it be theta squared?
What is it?
I wrote 4 times theta.
You have a calculator.
Pi over 4 times theta.
This is theta, no?
No, you're plugging stuff in for theta.
This, just forget
You're
it.
replacing theta.
Forget
Yeah.
about this.
Yeah, but you have to plug things in. Pi over 4.
Yeah, plug in.
Plug it in for theta.
and
Oh, yeah.
Replace theta with
Yeah,
pi
yeah.
over 4.
Which would be.
tangent
Just
of
pi over 4. And now.
which is rad 2 over 2.
What you guys
Which is 1. It's 1. Tangent of pi over 4 is 1.
Yep. Totally.
So just one half. Just one half.
For which one? As the final answer.
Tangent of 0 minus.
What's tangent of 0?
0.
Regularly.
Sorry?
Tangent of 0 is 0.
Equal to
Yep.
x negative.
So 0 over 2
So
is
what is it?
0.
No, it's 0.
yes.
I said 0 is
You gotta appreciate those moments. I've done stuff like that.
So what you just do, 1/2 is that final answer.
Yeah, that's what I was.
Yo.
So, looking at part C here,
Yeah.
and then, so by part C, since it's like 2 over x.
Yep.
And then
Well,
2x
you
to
don't
the
put
negative
square.
first power, but then trying to take the antiderivative of that.
Remember, that's the one.
Yeah.
That's the rule right there.
Secant squared, the antiderivative
What do I
of
take the
tangent.
derivative of to get 1
Not
over
tangent
x?
squared.
No, I mean like squared for the
natural
shape.
log of x.
No, why would
Natural log
you?
of the,
Because it's technically.
Oh, absolute value.
Kind of
which you can see saves your ass here because your inputs are negative.
No.
It's only the natural log.
Yeah, okay, yeah.
That, secant squared theta, that just turns into tangent. That's it.
Okay.
Okay, what's the antiderivative of 2 over x? 2 to the negative x. What's the antiderivative of 2 to the negative x?
Wait, how did you get. Sorry, how did you get.
0, so it's just 0 minus.
Don't you just do 1/2 minus 0?
Natural
Just
No, but I'm saying pi over 4 divided by 2 is what?
It's negative.
Well, no, pi over 2 is just 1. No, it's just pi. It's pi over 4. Pi over 4 is 1, and then there's a 2 over it, so it's just
Oh, yeah,
one
yeah,
log
yeah.
one.
The fuck are we doing?
I'm doing CRC.
What are we actually doing today, bro?
It's 2 to the negative x.
square root of 1 is 1. But if you subtract the 1 Oh, 2 oh, that's 9? 2 over x?
That's 2 to the negative x. Rewrite it as 2 to the negative x. Yeah, and then what is that?
The antiderivative?
The antiderivative of 2 over 2 to the negative x. Is that just
That's it, then we just plug it in.
no? That's not the natural log. I mean, that's not the antiderivative.
Yeah.
And we need to find the
Because you just
antiderivative.
rewrite it.
And then I just wrote.
Shouldn't we, the rule should be the same, no?
Wait, do you think we should be finding the
No,
Should be 2
no,
and minus x plus
It's
1.
not power.
Yeah.
It's not power rule. It's the natural log one. I think.
If that's not so, I'm me and you are fucked. Because me and you both got
It's the I think it's like
No, it was
negative
x
x.
to the 3x or something would be natural.
No. It would be the one with the negative x natural log of 2.
Hey, wouldn't the antiderivative just be this? Because you're check, isn't this technically check?
No. For the what's the antiderivative of 2 to the negative x?
Two to the negative. Are you talking about? You're on C, right?
Yeah.
Okay, so remember how -1 can't be like you can't really get rid of -1.
Yeah.
Because you guys are
Because
trying
the
that.
bottom would be -1 plus 1.
Yeah. So essentially, what you just change it to natural log of absolute value of x. But you also have the 2.
Oh shit, I'm still going.
2 in front of it.
Alright, let me catch up to you guys. This one is pretty easy, yes?
Yes.
You gotta like when there's a 3, so it just kind of goes back up. So the antiderivative was x cubed plus x. And then I just have to throw this stuff in. So throw a 3 in, minus throw a -1 in. So you get 30 plus 2, I get 32. Is that what you guys got?
Yeah.
Cool. Here, secant squared theta comes directly from tangent,
Over 2.
and then I just, why over 2? Yeah, I heard you guys mumbling, and I was like, why are they saying over 2 all the time? Why would I need an over 2? Is it secant squared of 2 theta?
If it was secant squared of 2 theta, then I would need an over 2 to kill the 2 that would come out. Well, this is, what's the derivative of tangent theta, guys?
Secant squared.
Which is exactly what that is. I don't need to kill anything.
Wow.
Look at you guys, just, what have I done? I like, the way I teach math, I worry, am I making a bunch of little mathematical Dexters just running around
So the
killing
answer is
things?
1.
Just put the plastic down. Okay. So I want to evaluate this from 0 to pi over 4. What's tangent of pi over 4?
I don't know. Huh?
That's
1.
1. What's tangent of 0?
0.
So that's kind of trippy.
The integral of this funky function from 0 to freaking pi over 4 is
1.
1.
That makes sense.
That's nice. If it makes sense, that's awesome. This one, now I want to show you something. What does this symbol here represent again?
The area under. The area under.
Sure, but more exact, directly, what does it mean?
The area.
No, what did it replace?
The sum
Oh.
Sum, good. It's an infinite sum, yes? Any constant, anytime you want to, if there's a constant multiplier inside, you can just factor it out. That symbol is literally a bunch of additions. If every single term has the same number in it, can't I factor it out? You could have done this problem without this, but I just want to show you. If you want to get your constant out of the way, you are allowed to all day.
You're left with 1 over x. Which is
And 1 over x, what do I take the derivative of to get 1 over x?
natural log.
Natural log of? Yes. And now you can see how that's very necessary because I'm trying to throw negative shit inside there.
How would you do it if you don't factor out the 2? What would?
Oh, then it would, inside you'd have to realize that this is 2 times 1 over x, this is 2 times natural log of x. It's just easier if you move it out of the way, then you can focus on what is really there. So a lot of times, if you have a multiplier, a constant multiplier, you can just move it out the way. Get out the way. Okay. Now what do I do?
No, you just
Plug in
plug
the
in.
negative.
Plug in stuff, plug in the -1, minus, plug in the negative e. What's the absolute value of -1?
1.
What's the natural log of 1? 0. What's the natural log, what's the absolute value of negative e?
E.
What's the natural log of e?
1.
Okay. Hooray. Why does it make sense it's negative? If I graph 2 over x, it looks like this. And so below 0, it's going to have negative area. Yes? Okay, do you have to do that or know that or think about that? No, but it's nice to know, hey, I expected a negative answer here. Hey, I'm walking. I'm sorry. Sorry. Hey, I'm expecting a negative answer here. All right, sorry. Terrible. Part D confuses the shit out of some people, but do you guys see how that itself is just the answer to the derivative of something, which means I know the antiderivative? What do I take the derivative of to get 3 to the x natural log of 3? 3 to the x. So some people look at it and go, what this shit was supposed to do with the ln3? Oh my god, no. That is exactly the rule for 3 to the x. This would be the derivative of it. So the antiderivative of it is 3 to the x. And then I plug in 2 and 3. 3 cubed is 27. 3 squared is 9. I get 18. Yay. Now, I need you to remember, every single problem we've done so far would have been an entire page of, yes? Okay, just to remind you guys that thank the gods we're able to do shit. I mean, make this easier.
Who came up with the F-Talk 2?
Oh, who came up with it? Oh my gosh. Was it Newton or Leibniz? I don't remember now. I think 2 people came up with it at the same time. I don't remember who we give. Newton, no. I have to look at it. Newton and Leibniz. But yeah, so there's a big, it's kind of funny you say this. There's a really interesting, it's kind of like, you guys know what I mean when I say who shot first in Star Wars, sorry? Who shot first? I don't know if you guys, okay. There's a big argument in math. Who came up with calculus? Some people say Newton did, some people say Leibniz did. But they probably came up with it about the same time. So who came up with it? Those 2 guys. Probably stole it from somebody else, but they shot them, so it's okay. Okay. How do I integrate? What's the antiderivative? And I'm going to stop saying that, by the way. I'm just going to, how do I integrate e to the 3t?
E to the 3t.
Almost.
Plus,
Divided by
3.
Good, right? And I want to evaluate that from natural log of 2 to natural log of 3. That seems very exciting. I'm going to write this a little bit. I'm going to write 1/3 e to the 3 ln 3 minus 1/3 e to the 3 ln 2. Is that cool? Now, if you just circle this, you're going to lose points. Because you can simplify this.
Natural log of 2.
What would these do if that stupid thing wasn't in the way? It would cancel. So how do you make him get out the way? Bring it back up. Yeah. Because what do logs have the power to do? They can take the power down, which means they can put the power back up. So I can rewrite this in all the room I've given myself here. E to the ln 3 cubed minus 1/3 e to the ln 2 cubed. These die. What's 3 cubed?
27.
Divided by 3?
9.
What's 2 cubed?
8.
Divided by 3? What's 9 minus 8/3?
27 minus 8. 19.
Well, e to the natural log cancel out, right?
Yes. As long as you get the coefficient out the way, they can actually attack each other and kill each other. That's what they want to do. So I just let them do it. Okay. How do you guys feel? Yes? I'm sorry? Yeah. Are you good? Okay. How do you guys feel about this? So now that we know, so this is trippy because it felt like, so here's something that doesn't happen as bad in summer as during a regular semester. My hand. It seems like there's 3 ideas. There's derivatives, right? And we make limits to go towards derivatives. There's antiderivatives, and then there's area. And today we figured out, oh, the area and antiderivative are actually connected. So there's really just 2 ideas. There's, I appreciate, thank you for that. So there's derivatives, and then there's integrals. Integrals can be used directly for antiderivatives if I just don't put limits on them, or they can be used to find areas. You guys with me? So that's why I said at the beginning of the class, there's only 2 things we did. We learned derivatives, and we learned integrals. And then we used the shit out of them. So the one thing I want to, if there's no questions on any of this, well, actually, let's take a look at this. This might not be bad, because tomorrow we got that quiz just on antiderivatives. What do you guys think about this? Just look at all these, which one of these freaks you out the most? I know which one would freak me out the most if I were you. Huh?
D.
Which one?
D.
D? This one? Okay, I don't blame you. It looks like there's a lot going on there, but there really isn't. How many terms are on the bottom of part D?
1.
And whenever the bottom's got 1 term, you can break the shit up.
Simplify, simplify, simplify.
What's the
Antiderivative of each
what's
piece.
the antiderivative of pi?
What is pi? It's the number.
So
So
0.
what's the antiderivative of 3? Not derivative.
Pi to the x. Pi times x.
Almost. You're missing two things.
C
It's not pi x.
Pi t.
Pi t.
plus C.
Okay. Pi t plus c. Bam. Real quick, you guys know this. If I said what's the antiderivative of x 2x plus 3, what's the antiderivative of 2x plus 3?
X squared
Make this capital
plus
Y.
C.
X squared, no, come on.
Plus C. Oh, plus 3x plus C.
3x, yes, 3x, yes.
Because there was a X.
If I put a 7 there, wouldn't this be 7x?
Yeah.
If I put 11, that'd be 11x. If I put negative 128, that'd be negative 128. If I put pi, it's freaking pi times variable. Since this is, so, you guys with me?
Yeah.
Do you guys remember how evil I was? I still am. When I said take the derivative of cosine 2? Just cosine 2, yes? And all you guys were like, sine 2, blah, blah, blah. No, this is, the derivative of this is 0, because this is stupid constant. So here, when I take the integral of a constant, it just becomes a multiple of the variable. So what would the integral of e dw be?
W.
EW plus C. Okay.
Wow.
EU plus C.
Sorry, I love that. Wow. That was something. Alright, so what do you guys think about... Alright, so you guys said you didn't like this, but this isn't as bad as it seems. I would have thought you guys would have said this one.
Why that one?
Look at it!
Can you just back-
I mean, how do I take the derivative of this? What if the question was derivative of this? What would I do?
Quotient.
And integrals do not have a... They can't. They have to undo derivatives, yes? So the fact that nobody said this one makes me a little concerned. If we really understand integration, that should give us the most worry. But what saves us is the stupid thing I kept saying. What's the phrase I've said just about the most?
Factor before you
Simplify before you attack it with calculus, yes?
Wow.
All right, so do me a favor. Try A and E real quick.
Try part A and part B. Part A.
So 2 over x minus 3, and then you integrate
Huh?
to on the bottom for e you factor it. Once you simplify, it would be 2 over x minus 3.
Don't let everybody know though. You gotta let them get there.
And then integrating that would be natural.
Don't say it.
Oh, I'm asking.
Don't. Just keep it to yourself. I want everybody to have their own chance. Where are we at? Oh, here. Absolute value plus C. Yep.
Are we?
That's it.
Oh, hell yeah. Hell yeah.
I'm not sure why you wrote x squared there, but yeah, you got the right answer.
Oh, because originally I tried to take the derivative.
Oh,
Tried to
you're
get-
doing okay. All right, let me catch up to you guys. How do I integrate x to the negative 2?
X to the negative 1.
Yeah, you add 1 to the power and you divide by the new
Negative
power.
1.
Keep going.
Minus 3x plus c.
Yep, good. The only power on an x that the power rule can't handle is a -1 power, and thankfully natural log helps us with those. So part E, first step is,
Simplify.
yeah, take a 2 out. The bottom is
X minus 2.
X minus 3.
pi.
2 over x.
And if you wanted to, you could take a 2 out like this, and you could focus on this. What is the integral of this?
Natural log of x.
Okay, natural log of,
Absolute value of x minus 3.
Plus C.
Plus c.
done. You could take the 2 up if you want to, who cares?
That's done.
How you guys doing?
Let's do c.
Yeah, we'll do the other ones. I want to do those two first. Yeah, what about C? What the shit, Jeff?
Secants.
You, now listen. If I ask you to do the derivative of ratio functions, can you just do the derivative of the top over the derivative of the bottom?
No.
You have to use quotient rule, correct? Now, if you don't do anything with this function, you can't just integrate the top and integrate the bottom. Right? Derivatives don't even work that way. So there is no product rule for integration. There is no quotient rule for integration. There has to be an answer to product rule. There has to be an answer to quotient because it's trying to undo what derivatives did. Whatever derivatives can do, integrals can't. They're trying to undo it. Thank the gods, C is the same first step as E basically. Not factor, simplify.
So what, it would just be sine, cosine, then you flip this.
Yeah, just make everything in terms of sine and cosine. So tangent is
Sine, cosine.
sine over cosine. Secant is,
1 over.
so the over cosines cancel. So I get integral of sine. And what's the integral of sine? Negative cosine plus C. Nice. Okay. And then the last problem for the day, kids. Part D. Do it. I'll wait. Sorry, did I go too far? That's just that, right? Last problem for the day. Do part D.
3 over 7, right? That's,
Huh?
that's how it's rewritten. 3 over 7.
What?
The rad.
No. What's in the bottom of the planes? What's the root? What's the root? Third root. So what's on the bottom? 3. 7 over 3. I think that's the opposite of what you said.
Yeah.
Yeah, okay. And if you're not really sure what's happening on part D, what's being divided by x squared? Everything. So put that over x squared down and then just simplify. So when the bottom is one term, wow, that kicks so much ass. Just split everybody up. When the bottom is more than one term, like that one, you're like, oh shit, please factor. So that's all you can really try to do.
I found the second and the third term, but I don't know the first one. What'd you get for the first one? For the 7 over 3.
Is everybody cool with that? 7/3 minus 2 is 1/3. I kill an x. And then this one I'm going to pull it back up because I know this is going to be a power rule thing, so I want to make it look like a power. What's the integral of x to the 1/3? Don't overthink it. No.
No, it would be.
Oh, I'm sorry. What'd you say?
1/4 x to the 4 thirds.
Almost. So 1 plus 3 is 4. So the power goes up by 4. I'm sorry, up by 1. And then I divide by the new power, which means multiplied by the reciprocal of it. So 3/4. What's this, of course?
-4 natural log of absolute x
Yeah. And of course, this guy.
is the natural log of absolute x.
No. Nope. No. When's the only time The answer is natural log.
This one at the bottom. It's linear. Is that linear? No. So what's the only time that the add 1 divide by the new power rule doesn't work is when the power would be -1. Because then the new power would be 0 divided by 0, and then, we create black holes and whole civilizations.
So what? -2x to the -1.
Yeah, so this will be, what's the new power going to be?
X to the -1.
Good. And then you divide by the new power. Yeah, you got it. Plus c. So you get 3/4 x to the 4/3 minus 4 ln absolute value of x minus 2x to the -1 plus c. Good.
Wait, how did this x to the 7/3 over x squared turn into x to the 1/3?
What's 7/3 minus 2? That's 7/3 minus 6/3.
Oh.
Yeah. Okay.
Should have answered.
You ready? Sorry?
You should have answered.
I guess I can. There. It's right there. This tiny little thing. Real quick. How do I subtract 1 from a power? I subtract the top minus the bottom, right? So here I gotta subtract 1 twice. 7 minus 3 is 4. 4 minus 3 is 1. Hey. Oh, okay. I personally think that's enough for today. We have we have 2 sections in chapter 5. 5-4 we basically did already. But obviously I'll talk about it tomorrow. What else is happening tomorrow? Quiz.
4749.
4749. When's our next test? When's our final?
16th.
Which is when?
The last day.
Is it?
I was the first day of class 2 weeks ago.
You guys realize it's next week?
Yeah.
Is our final?
Oh, yeah.
So
Feels
the
like I
six-
was just telling you about the syllabus.
The
Because
16th
you
is
were.
the last week. I mean, it's the last day.
Good point.
16th is the last day.